in this case, is that standard form of a circle? Does that look like what we just wrote there? Okay, this you can't put on your card because this is an actual example. So all I'm going to ask you is what's the center and what's the radius, because those are the only two things you need to know in order to do a circle. Okay, you said 7 and 3? Do y'all agree with 7 and 3? Okay, what did we learn about anything that is in a quantity? Do you keep the same sign or do you change it? On the vertex of the parabola, when it was in the quantity, you change it. So if you see a quantity squared, it's going to reverse. Obviously, if there's x, I'll give you another hint throughout this entire section. If there's x in the quantity, that's giving you the x coordinate. If there's y in the quantity, that's giving you the y coordinate. So this would be positive 7, negative 3. Change your signs when you take it out of a quantity. It'll be the same on every single one of the conic sections that we do. Okay, now, how do I get the radius? If that's 49, I get to do square root of 49, which would make the radius a nice round 7. Now, do they have to give you, does the radius have to be a nice number? No, it doesn't have to be, and they're not all going to be. That one came out nice. Okay, I'm not going to actually pull up graph paper to do this, but if I said graph it, how would you graph a circle? How would you graph that? You would go plot the center.
And go 7 up, down,
Yeah.
right, and up.
I would go plot the center, then, yes, she's correct. If my radius is 7, can't you just count 7 boxes in all 4 directions? And then you attempt to draw a semi-round circle. If I can't draw perfect circles, I don't expect you to either. So, but yeah, that's all you'd have to do is you'd have to count 7 boxes in each direction from the center. So in this case, counting 7 to the left, I would be sitting right here on the axis. 7 up is going to be up above somewhere. I'm going to run out of room, but I would get a circle out here somewhere. I'm going off the screen, but my circle would come around and, oh, it's too far, come back up. But you just count 7 boxes every direction, and you would have a circle. So not a major event. Okay. One other question here, because this sometimes gets people. What if I gave you a circle like this, where it's x plus 13 squared plus just plain y squared equals 24? What do you do with it when the y doesn't have a quantity? Where would you put for your center coordinate? Okay, x is negative 13. Joel says 0. What do y'all think? 0, 1.
0.
Because that's technically y minus what number? 0, because there's nothing there. So if there's no quantity, you just leave a 0 there. And you're done. So at the center, how would I get the radius on this one? Square root of 24. Okay. So then I would want you to break it down and reduce it. You can't. It's not going to come out an exact number. 24 would break down though as 2 times square root of 6, and I would have it broken. Okay, so not bad. Circles, right? That one, if I asked you to graph one like that, you have to turn that to a decimal and whatever. That would be 2 point some. It's probably 4 point something, close to 5-ish. You just have to guesstimate by decimal. I think, if I remember right, the ones I asked you to graph, I used ones that had nice numbers on them, because that wouldn't be too fun to graph. What if I go backwards on you? What if I say, write me the equation, and I tell you the center is at 7, negative 4, and the radius is 3 square root of 6. And I say, write me the equation for that. Okay, so it would be the quantity. because you're going to change signs. So yes, it's going to be x minus 7 squared, y plus 4 squared, and then if you square both of them, square root of 3 would be 9, square the square root, you just get rid of the square root, so it's really just 9 times 6 or 54 then. So you just, if you have something with square root, just square each of them and multiply it together. And to that, you wrote the equation of the circle. Woo, exciting. I'm boring you, it's too easy. There's no challenge. You need challenge. I can see it. Okay, well, I got one more circle problem for you. You're going to be so excited. Last block, they jumped up and down for joy over this. Couldn't get them settled down. This, too, is the equation of a circle. Does it look like standard form? It doesn't quite look like standard form. I don't think I can just read the center and radius out of it just the way I want. So somehow we have to do some magical algebra on it, because we want to get it down to the point that, yes, it's a quantity squared plus a quantity squared equals some number. We have to get it into standard form. We have to make it be perfect quantity squared. Have you done that any time recently? Made something become a perfect quantity squared? Just did it on the test. Completing the square, yes! Woo! Yeah! Look excited, guys. I knew you'd be delighted. Yes, it's completing the square, but not only do we get to do it once, we get to do it twice. Because we have to have 2 quantity squares. Okay, so what was the first step of completing the square? You couldn't have numbers, x squared, remember the squared number, you couldn't have any number in front, no coefficients. Okay, a big hint here, we'll actually go over this later, so you don't need to write it down right now, but if it's a circle, it will have x squared and y squared will have the exact same number in front. The coefficient will be the same. That's one of the ways we identify a circle, is that the coefficients in the front are the exact same thing. So how do I get rid of the 2? We divide them. But if I divide those 2 by 2, I get to divide everything by 2. So now I'm going to be down to x squared plus y squared, 6x minus 10y minus 2 equals 0. Do you like the order it's in? Because if I'm going to complete the square, don't I kind of need the x's together and the y's together? Yeah. So we want to rearrange. You want to get your x's together, so I'm going to do x squared plus 6x, and I know I'm going to complete the square, so leave a gap. I'm going to put a number there to complete the square. Then I'm going to add my y squared, my negative 10y, and I'm going to leave a gap. And Haley says I'm adding the 2 over. Do y'all buy that? Yeah. Because the 2 is not going to be the right number to complete the square, so yes, we're going to throw it to the other side always. Get it out of there. Okay, so what you're actually doing here is you're just completing the square. You're going to have a trinomial here, 3 terms, and then you're going to have another 3 terms. We just have to complete the square twice. So what's half of 6? Half of 6 would be 3, a positive 3. So when I square it, I'm going to get 9 as my number to complete the square. What do I have to do to keep the equation balanced? Yeah, if I add 9 here, I add 9 here. So then, I have to do it again with the y's. I have to go complete the square. So I have to look at it and go, okay, what's a number I could use to complete the square here? I need another color. Okay. So what's half of 10? Negative 5 squared would be 25. So I would be adding 25 to both sides. And once again, most common mistake is forgetting to add to the other side. Do it all the time. So what do I get when I do this trinomial? X plus 3 and y minus 5. Because you always take that number you did the half, that's why I wrote plus 3 there, because that's the number I put in. Half of this one was negative 5, that's the number you'll use. And then you add up over there, and did I give you a good number or a bad number? 36. I gave you a good number. So what's center? So the question is to change the signs or not to change the signs? Yeah, change the signs. So negative 3, positive 5. And the radius is just the square root of 36 or 6. And ta-da, we found a non-circle. That's all we have to find, the center and radius. No, wasn't terribly painful. Woohoo, we're excited. Completing the square is kind of fun. So that's it for circles. That's all you can do with them. They don't have a lot of pizzazz. So, and I'm going to